Thank you very much for giving me the opportunity to talk on my research interest, and particularly on, I think, possible cooperations within the HEAS network. And I have some suggestions that may be interesting that we can really make in the future in our in the HEAS network. First of all, my research interests are evolution in contemporary societies. We know meanwhile, by evolution in contemporary societies, we know meanwhile that evolution did not stop. So evolution still goes on even in modern societies. There's a lot of selection pressure, for instance, status and so on, which also influences our demography. This is called evolution demography, how our evolutionary predisposition influences our demography, how many kids we get, and so on and so forth, which has a lot to do with behavioral anthropology, and of course, genetics is always a background. So we know many of our attitudes, of our fertility attitudes, behavior, have a genetic background. And very interesting for me personally is with a cooperation with archaeology, from evolution anthropology, we have really the opportunity to see evolution at work, in fact. Because usually we have only a very limited time amount in contemporary societies, but if you use genetic data, social data, archaeological remains, and so on, we possibly really may see in the last 2 to 4 or 5,000 years evolution action. So what are my particular interests? With the social status, sex differences, particularly mating and reproductive success. As we know, as I said before, male social status is usually positively associated with the number of children a man has. Evolution, behavior genetics of religious behavior, which is from small tribal gods, but they're not really interfering usually from tribes, not interfering with the faith of people, but big gods which really have a moral instance, are really punishing and really merge in the first big settlements, the big gods that really enforce cooperation, which really punish. If you look at any religious text from Quran to the Bible, you really see the big punishing gods. So with a big evolution from small tribal gods to big gods. Of course, closely related to this very hot topic, in my opinion, is the evolution in behavior genetics of in-group versus out-group behavior. We know that xenophilia as well as xenophobia has a strong, reasonable genetic background. So if you're more xenophile or more xenophobe, it not only depends on your education, not only depends on the environment, but also depends on your genes to some extent. 20 to 40% in fact. And this of course influences homogeny inbreeding. And this is closely linked to this contemporary migration integration, particularly why societies really act in a way as they do on, for instance, the migration flows that flow in 2050. Okay, opportunity to do so is maybe reconstructing behavior and attitudes of our ancestors by the so-called polygenic risk course. Reconstructing behavior and attitudes of our ancestors by mapping the polygenic risk course that had been derived by modern behavior studies. And you can, if with modern data, with modern DNA data from modern humans, you can predict some amount behavior only from polygenic risk course or attitudes, for instance, only to a small amount. And my idea is not only to map this data, polygenic risk course, on recent DNA data from recent humans, but also on ancient DNA, so that we excavated and to look how the people may behave, what attitudes did they have, also their illnesses, their diseases. So this would be a bunch of questions. So as meanwhile, thousands of Shiva studies had been carried out, and each study did really generate polygenic scores, and maybe it's very interesting to map it on ancient DNAs. And so we can really get an impression of a cultural and genetic evolution of attitudes and behavior over a relevant time frame, not only 10, 20, 50 years, but you know, for 500 years, some very interesting and very prominent studies have been published in Science really showing that evolution, you can measure evolution in the genes for 500 years. And with the ancient DNA, we maybe have a possibility to really evolution for 5,000 or more years, in fact. But not too old, because people should be related to us. If we're too far away, the polygenic risk course wouldn't be less accurate. So how the genetic approach risk could derivate, you have really the modern cheaper data, you really generate some weighted, some beta values, and with beta values it's complicated, it's really some stuff from bioinformatics, you can map it to ancient DNA, maybe you really extract from skeleton data in fact, and maybe you can come together with material remains and the progenic risk score, you may come to some impression how people did behave. How was the genetic cognitive ability? So some questions, some behavioral types, some attitudes, and some progenic risk scores are for me of particular interest. Of course, the genetic cognitive ability. How clever had they been, our ancestors? Religious participation. How strong was affiliation to a religion? How much interested are the people in religion? Maybe the difference between populations, we don't know. Dissocial behavior, risk-taking, violence. Do really some communities that really had been engaged widely in warfare, do they have more alleles fostering and encouraging dissocial or risk-taking behavior, violent behavior, addiction of course. And very interesting as you know, with our conservative versus liberal attitudes or political attitudes, if we are left or right wing, have also a very substantial genetic basis. So is there also a basis in our ancestors? I think yes, we have to, but we don't know. And of course, in-group versus out-group attitudes, xenophilious versus xenophobic attitudes, depending on external and cultural conditions, marriage rules. Are some individuals more homozygous due to high inbreeding frequency? Maybe, we don't know. It would be very interesting to see. And last but not least, evolutionary benefits of male social status. We know from every culture, also in modern societies, that men with higher social status have higher access to fertile females, are more often choosing to marry into cohabitation and so on, and thus have more children and remain to a lesser extent childless. And is it possible to really see the genetic legacy of clan chiefs represented in further generations? To have here really their genetic legacy distributed in higher frequency to succession generation. So what would be my interest, in fact. Yeah, this is to say very in a funny way, this is the small Leberg of Niederfeldbruck against the big Leberg of Großmugel, whom of the chiefs or kings have more adaptive success, has more evolutionary success. Okay, thanks a lot for your attention, and hopefully this will work out in the future. Thank you.